Science marches into March and beyond with yet more discoveries. So here are 10 interesting scientific discoveries for March of 2025. Number 10. The star that lied about its age. This is a strange story. Cue in the star HD 65907. At first glance, this star looks like a relatively youngish star, about 5 billion years old. Not that much older than the Sun. But upon closer inspection, researchers noticed that this star actually doesn't behave like a star of that age. Firstly, the star contains much less iron than a star of its age should have. Instead, the lack of iron implies that this star was born much earlier, during a time when there was far less free iron available in the universe. It also orbits the center of the Milky Way differently than younger stars. It has an elliptical orbit that bobs up and down relative to the galactic plane, which is a hallmark of much older stars. Modeling of the star showed that it also lacks beryllium and lithium in levels much lower than younger stars. The Sun, in fact, has 15 times more beryllium. This basically knocks it out. The star is not young, because to get to high abundances requires several cycles of star formation and supernovas, yet the star still appears young. The answer apparently is that this star is the product of a merger of two much older stars, that when they collided, the end result was a larger, bluer, brighter star of a completely different class than the two stars that formed it. In the end, the true age of the constituent stars is about 11 billion years old, but the resulting post-merger star looks like a 5 billion-year-old star because that's about when the merger happened. This work may help astronomers understand another mystery. There's an entire class of stars known as blue stragglers that are bluer and brighter than their apparent age would imply, perhaps suggesting that star mergers of a certain type to produce this effect are relatively common. Number 9. The ear muscles we thought we didn't use. There are certain parts of the human anatomy that were thought to be vestigial, or basically useless. Most famous of these is the appendix, which for many years was seen as useless. But now that's debated, and it may actually have immune system and gut health functions that aren't absolutely necessary. Many people get appendicitis and have to have them removed, to no lasting health effects, but still useful in some ways in those with healthy appendixes. There are other examples of this, and one such case are known as the auricular muscles. These are actually responsible for the ability to wiggle your ears, for those that can do that, and they stem from pre-hominids. In short, they are what some monkeys and apes use to pivot their ears. We don't need or use that, but we still have the remnant muscles. And again, they were considered obsolete, but now that's being rethought. Researchers in Germany realized that these muscles actually do still activate when we hear sounds coming from different directions. So what they did was connect people to sensors and had them listen to audiobooks to see what happened with the muscles when they were listening intently. This was intentionally done with a female voice reading the audiobook, and then they put on a podcast hosted by a male host at the same time. So the people in the test had to focus on one or the other. They then varied the sound levels and conditions to see what the muscles did, and it turns out that the auricular muscles became increasingly active the harder the tests became. It's not known whether the action of the muscles actually helps in hearing, but the main use of this research actually may be in designing improved hearing aids and minimizing listening strain for those with hearing loss. Number 8. Polar bear antifreeze. One of the odd things about polar bears is that when you watch a wildlife documentary, other than when they are covered in blood from the latest meal, they look remarkably neat for an animal that lives in the Arctic. In short, you never see their fur covered in ice. And as a bearded human that is used to cold environments, I can say that this is not the case with us. Indigenous people to Arctic regions where polar bears live long noticed this effect and used polar bear fur for specific tasks because of it, including using it on the soles of boots to prevent sticking to the ice when hunting for silence purposes. But it was unclear why ice simply does not stick to polar bear fur until now. One thing about polar bears is that they do not show up well in infrared cameras because they are insulated so well that the outer part of their fur is below freezing, even though the polar bear itself is quite warm and comfortable in its environment. That should make them ice balls externally, but that doesn't happen. It turns out that tests showed that the polar bear fur is essentially slippery, which meant it was 4 times easier to remove ice from polar bear fur than it was human hair, meaning that the animals can simply shake it off efficiently. But if you wash the polar bear fur, they lose much of the effect, so it's a sebum oil coating causing the effect. In this case, the sebum secreted by glands next to the hair follicles lacks a common chemical called squalene, but does have unusual fatty acids for a mammal, which are possibly unique to the polar bear. Inuit people may have always known this, as they prepare polar bear fur in such a way as to preserve the sebum, which other methods of preserving fur would not. The use of this work is pretty obvious. It will help develop better ski waxes and even hair products for people that work in cold environments. No more ice in the mustache when climbing Mount Everest. Number 7. Hidden hydrogen. We already live in a world that uses natural gas as an energy source, though at this time it is mostly methane. But there's always been another option as far as flammable gases go, and it's hydrogen. But methane has a downfall. It produces carbon dioxide as a byproduct of its combustion. But interestingly, hydrogen does not. It produces plain old water. And so far it has not been well constrained just how much free hydrogen reserves Earth has. It certainly has a lot of it, but that's locked up in the water. So recently, researchers tried to constrain just how much hydrogen Earth has that can be economically mined and used in energy production. It turns out that it's a lot. Trillions of tons, and it could provide 200 years of carbon-free emissions powering the globe if we can harness it. But that's the trick. It's still unclear what deposits would be viable for mining, and what ones are simply too deep and inaccessible or too small for commercial use. As an aside, Earth actually produces geologic hydrogen, known as white hydrogen, as part of geologic processes, and there are areas of Earth where hydrogen is just seeping out of the ground and going into the atmosphere, which Earth can't hold on to hydrogen, so it's simply lost into space as the solar wind strips it off. So the stuff is free for the taking. It's just that industrial processes produce enough hydrogen for our needs, and it was still unclear until relatively recently that Earth could even have viable deposits of geologic hydrogen. But it seems it does, potentially offering us an important new clean energy source. Number 6. Jupiter's red spot is acting strangely. One of the key identifying features of the planet Jupiter is its great red spot. We've tracked it for centuries, as early as the 17th century, and seriously and reliably ever since the early 19th century. And one thing it's been doing on and off for quite some time now is dwindling down. It was once large enough to engulf 3 Earths, but now it's down to 1 to 1.5 in its apparent size. As of January, it was down to just 8,700 miles in diameter, and the trend towards it diminishing and potentially eventually shutting down continues. But it may not actually be shutting down. It's possible that the winds that contain it actually are constraining it down into a more durable shape, and that human observation caught a fluke expansion of the storm. It's not really clear how storms in Jupiter's atmosphere dynamically act. We know Earth storms, but that involves things like hurricanes weakening as they make landfall. That doesn't happen at Jupiter. But it may be that wind shears can tear the tops off storms and cause them to weaken. But storms at Jupiter, and indeed the red spot, can absorb and incorporate smaller storms into it, leading to a complex mix of weather. Other mysteries about the great red spot include why it changes colors as it does, which may be due to fluctuations of ammonia breaking down in Jupiter's upper atmosphere, in addition to how much longer it will last. We do know that the great spot at Neptune that Voyager 2 observed in 1989 was gone within a very short time after the passage. Number 5. The universe's first water. The question of just when water was available in the universe has been contentious and important, given that water is the best solvent we know of for life. There has been a trend of late in astronomy that certain chemicals that were expected to arise later in the history of the universe appear to have been present very early on, oxygen being one of those. And now the water molecule appears to have been present just 100 or 200 million years after the Big Bang, even predating the formation of galaxies. In the early universe, the elements in abundance were hydrogen and helium, but not oxygen, which is essentially, along with hydrogen, needed to form water. Essentially, oxygen formed in the first stars, but was propagated in galaxies by supernovae, and then the oxygen combined with the pre-existent hydrogen and water was born. It turns out, the rollback on when water was expected had to do with just how those supernovae propagated oxygen, which seems to have been more efficient than expected. It turns out that early stars, depending on their size, were able to produce and distribute oxygen faster, and that the first water molecules started appearing early, but that water, along with other molecules, oddly clumped through gravity and seems to have had a role in the formation of the second generation of stars in the universe. This may have huge implications on the habitability of very early planets in the universe. The conditions may have been better than we thought, and ancient life in this universe may be possible far earlier than we thought, once again complicating the Fermi paradox. Number 4. The Vesuvius Vitrified Brain. The eruption of Mount Vesuvius in 79 AD and what it preserved is amazing at archaeological sites like Pompeii and Herculaneum, but also sad in that sometimes, very conditionally, that volcanic eruption with its apocalyptic volcanic pyroclastic flows could preserve things through heat that do not really preserve quite that way otherwise. This includes scrolls that are now being deciphered in red, loaves of bread that carbonized and look almost identical to loaves of bread still available in Naples to this day, and humans where skeletons are preserved in cavities in the ash and can be reconstructed with plaster being poured in, or other means showing that person's last moment before death and being buried in the ash. But what generally did not preserve was soft tissue. It was just impressions that casts could be made from. But no longer. It seems that someone's brain from the ruins of Pompeii actually turned to glass and was preserved. Now it's volcanic heat we're talking about, so it's not a glass brain, just a vitrified tissue that's preserved. This man was found lying in his bed in Herculaneum. Perhaps that's all he could do, or what he decided to do under the circumstances. And basically what happened was when the intense heat from a pyroclastic flow hit, his brain almost instantly boiled, flashed to steam, and exploded. What was left inside his skull cooled after the pyroclastic flow ended and turned to glass. The remains even preserved brain structures such as neurons and axons, and there were even still proteins still preserved. Heat can do a lot here. It can vaporize things and turn things to carbon. But for it to have turned into glass, it must have involved a rapid cooling, a very sad end for whoever that was. But how this helps science is that it may be possible to design volcano shelters that can withstand the heat of pyroclastic flows in areas prone to that, to protect those that cannot, for whatever reason, be evacuated ahead of time. Number 3. Keep the spacecraft a little dirty for immune system health. It may not be a great idea after all to keep spacecraft as sterile as you possibly can. This has been argued many times before, but the bottom line may be that the human immune system needs to be kept stimulated to be as effective as it can be. And let's face it, if you want to be in shape, you must work out. Immune systems may work like that too, and need stimulus to keep them on their toes. That's a problem for spacecraft. One of the reasons the focus in space stations and spacecraft on sterility has been that contagious diseases that may easily be treated here on Earth are not so easy to treat in an environment in space, and not so easy to contain in such a closed environment where people are crammed together so dramatically. And this has been largely, though not completely, effective. There's very little going on the International Space Station in this regard, though not entirely. There are microbes aboard. The situation has led to unusual changes in astronaut health both on the space station and when they return, suggesting that there is value to a stimulated immune system, and that we may need to dirty up our space stations and spacecraft to keep the astronauts healthy. There are ways to do this because it is possible to fill a space station with bacteria that are not pathogenic yet stimulate the immune system. Number 2. Stone tools, habitat change, and monkeys. There actually is an endangered monkey known as a golden-bellied capuchin, found in Brazil that may be dealing with endangerment in an odd way, stone tool use. So the monkeys are threatened by habitat loss, deforestation, but also the conditions for them have been changing for several 100,000 years naturally. Yet sometimes colonies of them are found living outside of dense wet forests in more dry forest conditions that they are not completely native to. One thing researchers found is that the monkeys in the dry forest area use stone tools to split open palm tree fruits, yet those in their native habitat north of the area do not. This suggests that it may be learned behavior that allowed the golden-bellied capuchins that moved into the new habitat to survive, because easily accessible food is harder to find in that area. Oddly, this actually seems to have happened with humans as well. When we moved into new areas, specialized stone tool production occurred in response to the environmental change. We still do that. One will need an ice axe to climb Mount Everest, but you won't need one for Disney World. Number 1. The moon's discrepancies. There is an odd discrepancy with the moon. If indeed it formed after a massive impact of Earth by a Mars-sized object known as Theia, the moon shows 2 different time periods as to when that actually happened. One is from lunar rock samples, which generally places it at 4.35 billion years ago. Yet zircon crystals in those same samples give 4.51 billion years ago. New work may explain that gap. The 4.3 billion year date may not have very much to do with Theia, but instead, there was a later event that caused the moon to heat up again, and its surface to melt and solidify, resetting the dating used. The problem is that the moon was a lot closer to Earth in the early days and was much more subject to tidal heating, as its elliptical orbit in relation to Earth's gravity tugging on it and flexed it, much like what happens with Io today at Jupiter. And indeed, one of the ways to date the surface of the moon is its impact basins. And if those were reset, then the dating is off. This underscores a lot of uncertainties in planetary science. The circumstances of both the Earth and the moon, and how molten they were, or how early Earth gained its water, all play a role in determining the timeline of how the Earth-Moon system evolved. There are still many things to be determined, and the details remain unclear. Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently eyeing the moon suspiciously as though I haven't always done that. Yeah, so one age is like 150 million years older than the other age. The idea is that things got erased, and it actually is the older number based on the geology. But I asked the question, could it be a fake ID? What does the moon want? And be sure to check out my books at your favorite online book retailer and subscribe to my channel for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.